Okay, in this problem, we're going to find I1 using superposition. We can see where I1 is labeled. We use a problem-solving strategy entitled AC Steady-State Analysis, and also applying superposition. And if we look back at our strategy for applying superposition, the network containing multiple independent sources. Each source can be applied independently with the remaining sources off. Okay, so really we're going to perform the analysis with one source active at the time, and then we can add all those responses together to get the response with all three sources acting at the same time. So let's go through there and start doing it one source at a time. Then we turn off a voltage source, we replace it with a short circuit, and we turn off the current source, we replace it with an open circuit. So if we find the contribution from this source, we turn this to 0, well that's replacing it with a short, turn this to 0, and that's replacing it with an open. So when we do that, here's our resulting circuit. Okay, so notice now the voltage source was here, the 6 at an angle of 0, the 3 at an angle of 10 degree current source was over there, and we turn those off, we get to this. So now, let's simplify this circuit. For instance, this is in parallel with that. Okay, so parallel, so we can calculate an admittance. Okay. So Y here is 1 over J3 plus 1 over 4 minus J2, which is 0.2 minus J.2333 Siemens. And let's go ahead and convert that to an impedance. So here's 1 over Y, which is 2.1176 plus J 2.4706. Now we can redraw our circuit. And here's I1 prime, which is a contribution from the 12 at angle 0 volt source. Now, if we look, this source is actually going to push current around in this direction, which is the opposite direction for which I1 prime is defined. So yeah, this source is going to push current that way. So I1 prime is going to be minus 12 at an angle of 0 divided by 3 plus J2 plus Z. So I1 prime then is minus 1.33 plus J 1.16 amps. Okay, so that's the contribution from the 12 at angle 0 source. Now if we look, let's turn this source off, leave this source off, and turn this source back on. So now we're going to find the contribution from that 6 at angle of 0 source. The resulting circuit is shown here. So now we need to go through and do some analysis on this circuit. Again, we can simplify that. For instance, if we look, this impedance and this impedance are in parallel. So we have Y here is 1 over 3 plus J2 plus 1 over 4 minus J2. And we could calculate that. We don't need to, though, because really we want Z is 1 over Y. And Z turns out to be 2.2857 plus J 0.2857 ohms. So now our circuit can be redrawn as this. we've lost the current I1 double prime at this point, because when we combine those two impedances in parallel, we lost that. So let's call this current I2 double prime. Let's calculate it first. So I2 double prime then is 6 at an angle of 0 divided by Z plus J3. And that's 0.8561 minus J1.23. And now if we look back at our circuit, here is the current I2 double prime. So now we can use current division, because I2 enters here and it's going to split. So by current division, I1 double prime is I2 double prime times 4 minus J2 over 3 plus J2 plus 4 minus J2. And again, that's a current divider. We want the current through this impedance, so this one's placed in the top. And this turns out to be 0.1378 minus J.9475. Okay, so that gives us a contribution from the 6 at angle 0 source. Now we need to find the contribution from the current source. So we turn both of these down to 0. Our resulting circuit is shown here. So again, we're going to need to do some impedance combinations and admittance combinations. So if we start off, for instance, this impedance and this impedance are in parallel. So their admittance would be 1 over 3 plus J2 plus 1 over J3. And since these two are going to be in series, I'm going to go ahead and convert this to a Z. So Z is 1 over Y, which is 0.7941 plus J 1.6765. So now let's redraw our circuit. Okay, so now, if we look at our circuit, for instance, now we have a current divider. Current enters here, and it basically splits. And really, we're trying to get to this current. So let's calculate this current. I'm going to call I3 triple prime. Okay, so we're going to calculate that current, because if we look back in our circuit, this is I3 triple prime, then we can do current divider. So basically we can do two current divisions at this point to calculate that. So, let's see. So now I3 triple prime is 3 at an angle of 10. Now we want the current through this part of the circuit, so we're going to put this impedance in the top. So we have minus J2 over 4 plus Z minus J2. And that gives us I3 triple prime 0.3 minus J 1.2123 amps. So now we've calculated this current, which is this current. We need to do one more current division. Now we need to divide here, and since we want the current here, we're going to put this in the top. So now I1 triple prime then is I3 triple prime times J3 over 3 plus J2 plus J3, which is 0.4529 minus J.4557 amps. So now, I1, which is the current with all the sources active, is I1 prime plus I1 double prime plus I1 triple prime, and that turns out to be 0.7783 and minus 161.8 degrees.